Hello everyone and welcome once again to MS Maths and Stats. That's MJ Magic Studio to you. I'm your host, your host, and as usual in the ghost mode, Mohit Jain. And before we start with today's session, a small disclaimer. These all are typed in which we have seen on the screen of MCAT Global platform while students were writing exams of WIPRO assessment test. And the section is Quantitative Aptitude or Numerical Ability. So you might find something common with those questions, but there is no intention to infringe with the copyright of the questions of MCAT Global platform or SHL platform. So please, MCAT Global people, I'm not copying you. These all are the sample questions, just showcasing, just for practice for the student who aspire to write WIPRO assessment test in near future. So disclaimer done. So here are a few sample questions. You should practice these type of questions before you write WIPRO examination, and you know the drill. Please subscribe to the channel, pause the session, solve it yourself, and then look out for the solution. On this note, let's start now. The reciprocal of the HCF and LCM of two numbers. Okay, so HCF is reciprocal of 1 by 12 is 1 upon 1 by 12, that is 12, and LCM would be 312. If one of the number is 24, find the other number. We know that in case of two numbers, product of the numbers is given by the product of the HCF and LCM. So the second number is 12 into 312 by 24, 156. The second number or the other number we are looking out for is 156, option D. These kind of question you can find very easily in class 6, 7, 8, 9, 10 book, and it has been taken from those books only. So if you claim that this is your question, then it is wrong. This is just a question, just a property to solve, isn't it? What is the unit digit of the following sum? 1 to the power 1 plus 2 to the power 2 plus 3 to the power till 6 to the power 6. Okay, 1 to the power 1 is 1. We will just make note of the unit digits of these expressions. 2 square is 4. 3 cube is 27, 7. 4 to the power 4 is same as 4 to the power 2. 4 to the power 2 ends with 6. 5 to any power will always end with 5. And 6 raised to any power will always ends with 6. Now we just need to add up. 7, 17, 18, 8. 8, 5 is 3, that is 13s, and 3 plus 6 is 9. So last digit or the unit digit of the given expression is 9. Any other expression can also be given to you, so don't bother about it. Just do it, whatever numbers are given, and find. Okay, these kind of questions are also very regular on SHL or MCAT Global platform. This is just an example. What is the highest power of prime number contained in any factorial n? These type of question they will ask. What is the highest power of any prime number contained in the given factorial n? That means what is the highest power of prime number which can divide this factorial n without leaving any remainder? Process is simple. If I take this example, divide 200 by this prime number 5. We'll get 40. We'll just need to find that how many times it is divisible. No need to write the remainders if you get a remainder. Again divide 40 by 5, you'll get 8. 8 times. Again divide 8 by 5. You can divide 8 by 5 only one times. Forget about the remainders. Leave this top number and add the rest. 40 plus 8 plus 1 is 49. That means 200 factorial is perfectly divisible by 5 to the power 49. Answer B. So if for an example we take that factorial 100 divisible by 2 to the power x. 2 is a prime number, we'll follow the same process. Keep on dividing 100 by 2. We'll get 50, then 25, then 12, then 6, then 3, then 1. Forget about the remainders. Leave 100 and add up. 75, 87 and 10, 97. That means factorial 100 is completely divisible by 2 to the power 97. Practice this process. This is SST, Sundar Sasta Tikau process. Now the same type of question, but here is what is the largest power of 20? 20 is not a prime number, it is a composite number. Now what to do in case of composite number? Factorial n is divided by composite to the power x. Break this composite number into the prime factors. So we'll get 2 to the power 2 and 5 to the power 1. So we need to find that how many times it is divisible by 2 square, that is 2, and how many times it is divisible by 5. So if I go with 100, and in the previous example we have seen this, that factorial 100 is perfectly divisible by 2 to the power 97. Then half of 97 in whole numbers will be 48. That means it is divisible by maximum 48 powers of 2. Now we need to check that how many times it is divisible by 5 by using the same process. 20 times by 5, 4. That means it is perfectly divisible by 5 to the power 24. 5. Okay. Now, to make a 20, we need a pair of 4 and 5. We have got 48 4s and 24 5s. So obviously, how many 20s we can have? It's like an arranged marriage. You have got 48 males and 24 females. And if a male and a female mean a pair, then how many eligible pairs of male and females we can have? We can have only 24 pairs, isn't it? So, factorial 100 is completely divisible by 5 to the power 24. It is completely divisible by 4 to the power 48. That means it is completely divisible by 20 to the power 24. Option C would be the pick. Now this was the detailed discussion about how to do it for composite number, but you can apply your simple logic that if you have 2, if you have 5, obviously you will get more powers on 2, you will get less powers on 5. So you can only check for 5 also in this case and you will get the answer, that is 24. Okay, one more from numbers, and now what we have. What is the least number which should be added to 1330 to make it a perfect square? Either we should know that perfect squares of few numbers, it is 1330, or we can use the traditional method to find the square root. 3, 9, 430, 3 into 6, then 6 times 36, 39. It will go, and we will get some remainders. That means we are looking out for a number which is more than 36, just more than 36. That is 37 square. 37 square is 1369, which is just greater than 1330. We need to add 39 to make 1330 a perfect square. This should be the least number. Option E is the pick. Okay, the next one on the screen. Which number should be multiplied by 31 so that it will have 3 prime factor? Now we know 31 itself is a prime number. So we need to multiply this with such a number which have got 2 prime factors. So out of the given options, 6 is a number which have got 2 prime factor, that is 2 and 3. 8 is 2 cube which have got only 1 prime factor, and these are the 1 prime number itself. So we'll mark on 6. The product of two numbers is 2208. If the LCM of number is 552, what is HCF? We know that product of two number is product of HCF into LCM. So HCF is 2208 divided by 552. It will go 4 times. So HCF of the number is 4, that is option B. A question from Simplification. I believe that you people must be pausing the session and try to solve yourself. These all are a pretty common question which you might find if you are writing your WIPRO NLTH examination. Simplification, and we will use the BODMAS rule, which says first use bracket. 5 into, this is 18 by 2 minus 4 into 4 plus 1 by 4 of 16. Now is off, that will become 4. Then 5 into 9 is 45, minus 4 into 4 is 16 plus 4. So 45 minus 12 will give 33. So we'll mark on option D. A good question from remainder theorem, we can use it. 2 to the power 35 is divided by 5. The remainder is, we know that when fx is divided by x minus a, remainder is given by f of a. So 5 is 2 is square plus 1. If I write this as 2 is square to the power 17, that would be 34 into 2. So we'll get 2 into x to the power 17 is divided by x plus 1. So remainder would be 2 into minus 1 to the power 17, that is minus 2. Now if remainder is minus 2, we add the divisor to it to get the positive remainder. So we'll add 5, we'll get 3 as remainder. Now we may use one more process, that if a number is divided by 5, just find the last digit of the given number. 2 to the power 35. When 35 is divided by 4, we get 2 cube. 2 cube is 8. So last digit of 2 to the power 35 is 8. Now 8 when divided by 5 leaves remainder 3. We can also use this process. So here remainder is 3, option B. The largest measuring cylinder then can accurately fill 3 tanks of capacity 98, 182 and 266 liters is of capacity what? We are actually looking out for HCF of 98, 182 and 266. Let's use the traditional method. 266, 182, 484. 182 will go 2 times, 168, 70, 12, 14. Now 14, 84 will go 6 times. Correct? Okay. So that means 14 is the common multiple between 182 and 266, and 98 is divisible by 14 also, 7 times. Yes? That means HCF of these 3 numbers is 14. Answer is 14 liters. The LCM and SCF of 2 numbers are this. Prime factors of the product of the 2 numbers. Product of the 2 numbers would be 30 into 2970. That is HCF into LCM. So prime factor here we will get 3, then 10, 2, then 5. So now let me check this for 11. Yes, we'll get something for 11, 270. And here would be 27, 5, 2. So prime factors would be 3, 2, 5 and 11. 2, 3, 5, 11. Option A. The LCM of 2 numbers is 2516 and square root of HCF is 2. So root over HCF is 2, HCF is equals to 4. Then find the product of the number. Product of the number is HCF into LCM. 10,064. 10064. Yes, that we have in option C. Next question on your screen is from Radix. Yes, okay, base 2 is given. We need to convert this into base 10. So multiply this by 2 to the power 0, this by 2 to the power 1, this by 2 is square, this 0 by 2 cube, and this by 2 to the power 4. 16 into 1, 16. Leave these because 0 multiplied with any number will give 0. 2 square is 4. Add up 2 to the power 1 is 1 into 1 is 1. So that is 21. So 21 base 10 is same as 10101 base 2. That is in binary number system. Option D is the pick. Okay, one more from HCF LCM, and what we have this time. The LCM is 2000 and HCF is 500 of two positive numbers. Identify the pair of such number. HCF is 50, not here. HCF here is 50, fine. HCF here is 50, but HCF here is not 50. Now we are looking out for LCM 2000 multiplication. LCM should be 2000. So this is 50 into 10 and 50 into 4. So LCM is 50 into 10 into 4. That is 2000. Done. Option B is the pick. Find the largest two-digit number that can divide this, leaving remainder 1 in each case. Here first subtract 1 from these number and we'll get 672 and 864. Now what we are looking out for is HCF of these number. 672, 864, I'm using the traditional method, and 6391. 672, you go how many times? 3 times. 6 and 57. So you got what? 90, 96, 96, 192. It will go 2 times. That means HCF is 96. 96 is the largest two-digit number, which when divide these two will leave remainder 1 in both the cases. Great. Option C is the pick. A pie has to be divided among few kids. P get 2/7 of the portion, that is 28.57% of the portion, and S gets 5/8. 5/8, 12.5 into 5. 62.5%. Who amongst the two gets lesser share? Obviously P with 2/7 have got the lesser share. If only 2 people are there. Now few sample questions from probability, permutation, combination combined. Let's see what we have in the platter now. A quiz has one multiple choice question with 3 options and 2 true and false type questions. What is the probability of answering all 3 questions correctly? So probability of answering first question correctly is 1/3, second question correctly is 1/2, and the third question correctly is also 1/2, because for the first question we have got 3 options, for the next 2 questions we have got only 2 options, that is true and false. Since they are independent in nature, overall probability is 1/12, option D. What is the probability of making an even number of 4 digits using 1, 2, 3, 4? Only 4 digits are given without any digits being repeated. That means repetition is not allowed. Even digit of 4 digits. That means 2 or 4 will be occupying themselves at the last position. So for that we have got 2 options. And from the remaining 3 digits, 3 positions can be occupied in 3p3 ways. So 3p3 is factorial 3 into 2, that is 6 into 2 is 12. That is the total number of favorable cases that we will have. Now, total number of cases are factorial 4, that is 24. So required probability is favorable number of cases divided by total number of cases, that is half. Option A. Okay, on the platter of probabilities, next one, let's see what we have. A basket contains 4 strawberries and 8 grapes. That means 12 products. What is the probability that both the fruits drawn, that means we are drawing 2 fruits, from it are strawberries. So required probability would be 4C2 by total cases would be 12C2. Since nothing is given in the question regarding how the drawing is done with replacement or without replacement, we'll always assume this as without replacement and we will use the combination technique. 4C2 is 4 into 3, 12C2, 12 into 11, gone. So we're left with 1 by 11. Option B. V is guessing which of the two hands holds a coin. What is the probability that V guesses correctly 3 times in a row? Since there are two hands holding coin, probability of guessing it correctly first time is half. Second time will be also half and the third time will be also half. So the required probability we are looking out for is 1 by 8. Why it is half? Because we have got only two hands. Out of the two hands, one of the hand is holding the coin. 1 by 8, option D. In a non-leap year, that means we have got 365 days. 52 into 7, that is 364 plus 1 day. What is the probability that the last day, this day of the year starts with a T? Okay, this last day may starts with M, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday or Sunday. So for this last day we have got 7 options, out of which 2 are favorable because these 2 are starting with T, that is Tuesday and Thursday. So required probability is favorable cases divided by total cases, 2 by 7, option D. In an examination, a candidate is required to answer 5 questions in all, from 2 sections having 5 questions each. What are the total number of ways in which a candidate can select combination question, provided that at least 2 questions are to be attempted from each section? From this section, if he selected 2, from here he will select 3, or if he selects 3 from the first section, he will select 2 from the second case. So first case is, number of selection would be 5C2 into 5C3. 5C2 is 10, 5C3 is 10, that is 100. Or second case, 5C3 into 5C2. 5C3 is 10 and 5C2 is 10 again. So total number of cases or total number of ways in which you can select question to answer are 200. Option A is the pick. If from a deck of 52 cards, 4 cards are to be selected and one card of it should be a spade, we have got 13 spades, and another card should be a heart, another one should be heart, and we have got 13 hearts. So first of all we need one spade that can be selected in 13C1 ways. Then we need one heart that can be selected in 13C1 ways. Now we need 2 more cards. In how many ways can these cards be selected? Now since 2 cards are already selected, now we are left with 50 cards, out of which we need to select 2. That can be done in 50C2 ways. Now it is not said that you need to have only one spade or one heart. You can have more than one spade and more than one heart, but you should have at least one spade and one heart. That's why the remaining 2 cards can be selected from the remaining 50 cards. Now 13C1 is 13, 13C1 is 13 into 50C2, and is matches with 13 square into 50C2, option B. Okay, another one from arrangements. How many 4-digit numbers can be made using 1, 2, 3, 4, 5, 6, 7. 7 digits are given, with none of the digits being repeated. Repetition not allowed. 7 digits are given. We need to take 4 at a time, and 0 is not included. We know that we can use our formula directly, that is NPR. So, number of 4-digit number we are looking out for is 7P4. That is 7 into 6 into 5 into 4. 20, 42, 840. Option B is the pick. Okay, the last one on this session, WIPRO Part 2, Quant's Sample Sure Questions. And it might look cliche, but please don't forget to subscribe to the channel. Do comment and do share and let us know which company's sample questions you want to solve along with us. The number of 5-digit odd numbers that can be made from 1, 2, 3, 4, 5. Only 5 digits are given. Odd numbers we are looking out for, and nothing is given about whether repetition is allowed or not. And when I give a glance on the options, it is quite evident that repetition is not allowed. Because if repetition is allowed, we would get a huge number. We will see that also. So if repetition is not allowed and we are looking out for odd number, that means in the last place we should have either 1, 3 or 5. That means out of 3 options, we need to choose any one option. Now for the remaining 4 places, we have got 4 options, remaining 4 options, which need to be arranged in these 4 places in 4P4 ways. So the number of 5-digit odd number we are looking out for is 4P4, that is factorial 4, 24 into 3P1 is 3, 72. And we can see that we have got 72 as one of the option, which is also the highest of the options. Now if in case repetition is allowed, then 1, 2, 3, 4, 5. In the last place, we will have only 3 positions. Either we can have 1, 3 or 5. But in these places, if repetition is allowed, first place, any of the 5 digits can be placed. In the second place, any of the 5 digits, third and fourth. If repetition is allowed, answer would have been 5 to the power 4 into 3. That is 625 into 3. 1875. But 1875 is a large number as compared to 24, 32, 64 and 72. Here automatically we have assumed that repetition is not allowed. Option D is the pick. So thank you everyone for participating. This is Mohit Jain signing off from MJ's Maths and Stats. That's MJ Magic Studio to you on this hope that I'll see you soon. Take care, do good and do subscribe to the channel also. I'll see you soon. Thank you everyone.